So, greetings once again. Let's begin by looking at the static routing. Now, this is the outline of what we are going to be covering. We are going to be looking at the static routing implementation, configure static and default route, configure summary and floating static routes, troubleshooting static route and default route issues. Then we shall look at the summary. This is the outline of what we are going to be covering in this session. Now, when talk about static routing, what is the use of this protocol and why do we have to look at it? We are going to see all these issues, but before we reach that level, there is what we call reaching a remote network. Reach remote networks. A router can learn about remote networks in one of two ways. A router can learn about a remote network in one of two ways. Now, what do we mean by a remote network? A remote network is the type of network that is not directly connected to a router. A remote network is a type of network that is not directly connected to a router. We shall see that one later on. But basically, what happens, a router can learn about remote networks either by the manual method, shall call that one manually, or automatically, and that one we shall call it dynamically. So with the manual way, remote networks are manually entered into the routing table using static routes. And also we have this other way how a router can learn about a remote network is by the use of the dynamic routing protocols. We shall see that these ones later on. So these are the two ways how a router can learn about a remote network. It is either by the manual method or by the dynamic method. Now, a static route is created, maintained, and updated by a network administrator, and this is done manually. Now, what I want us to know is that we are looking at a topic called static route, and here we are seeing that a static route, it can be created. We are going to see how it is created. It can be maintained, and it can also be updated. And who does that? It is the network administrator. So this is what we call the manual method. So a static route to every network must be configured on every router for full connectivity. A static route to every network must be configured on every router for full connectivity. Now, don't mind about what we are talking about, but the clear image will come out when we go to the practical part. Now, if you can look at this kind of topology, you can see we have PC1, we have PC2, we have, these are switches, these are two switches. We have two routers, router 1 and router 2, and also we have these other switches, this switch and this switch, and also we have these other pieces. And we have our internet. So what happens is when you look at this topology, the first thing you need to know is how many networks are we having in this kind of setting. Now when you are counting the networks in the topology or in any network design, you simply count the cables connecting to the routers. You simply count the cables connecting to the routers. That will determine how many networks you have in any network design. So let's count this. This is one cable. This is the second cable. This is the third cable. As you can notice, I'm only counting cables for connecting to the routers. This is 1, this is 2, this is 3, this is 4, and this is 5. So this means in this kind of topology we have 5 networks. We have 5 networks. Now let's look at router 1. Router 1 has 3 networks which are directly connected. In other words, we can see there are 3 cables. This is the first one. This is network 1. This is network 2. And this is network 3. So these are directly connected to this router. But when you look at these other networks, like this one here, this cable is not connected directly to router 1. So I can conclude and say this network here is remote to router 1. So we have this as a remote network to router 1. And also this is another remote network to router 1. Remember, I told you a remote network is a network that is not directly connected to a router. I hope that one is very clear. Now, we can see router 1 only has 2 networks that I need to know about. So those are the remote networks I've just discussed. This is one, and this is the second one. So router 1 needs to know about these remote networks. And here it says, so I just need 2 static routes to reach those networks. So what happens? A static route, the topic we are looking at, static routes help routers to learn about remote networks. Static routes enable a router to learn about remote networks. So when I'm on router 1, I need to create 2 static routes. Reason being, I have 2 remote networks. This is 1 and this is 2. Remember, I told you, when you are counting remote networks, when you are counting networks, you simply count the cables connecting to the routers. And I started by showing you that this is 1 cable connecting to the router, the second one is here, the third one is there, the fourth one is that, and the fifth one is that. So this means in this kind of setting we have only 5 networks. Now when we come to the remote network, when we look at router 1, we have 2 networks, this and that are not connected to router 1. So we shall say these are 2 remote networks for router 1. So that is why we say router 1 only has 2 networks that I need to know about. So I just need 2 static routes to reach those networks. Now when you come to router 2 also has 2 remote networks. This and this one here. So the whole concept here is you have to know how to identify the remote networks before you begin configuring your static routes. Now for the dynamic routing, we shall look at that one later on. We shall look at protocols like EIGRP, RIP, OSPF, but that one we shall look at it later on. So those are what we call the dynamic routing protocols. So that one, don't mind about that. Our focus for today's lecture is on static routes. So why do we use static routing? Why would a system administrator, why would a network engineer go for the option of using static routing? We have some few reasons. Static routing provides some advantages over dynamic routing. Now don't forget, we have what we call manual way of learning about remote networks, and also we have dynamic way of learning about networks. So the manual is what we call the static, and the dynamic, these are the protocols like EIGRP, OSPF, RIP. We shall see that one later on. So why would someone go for the static rather than the dynamic? We have some reasons here. Reason number one, static routes are not advertised over the network, resulting in a better security. This is a key point here. Most of the hackers, people who penetrate networks without being authorized, you have heard of hackers, those illegal users who penetrate into systems without being authorized. One of the things they use to get information regarding any network is what we call updates. Those updates, they are very dangerous. So when you look at the dynamic, most of them, they send updates. Anything, any network change, it is going to be sent out. And the hacker can take advantage of those updates to know about the information regarding your network. But now when you look at the static routes for them, they don't send out any information. They don't send out any updates. And that is why they are categorized to be more secure than dynamic. So one of the reasons why we use static route is because it offers a better security. Second reason why we use static routes, routers don't share static routes with each other, thus reducing the CPU stroke RAM overhead and saving the bandwidth. So someone who is going to use the static route, someone using static route is not going to waste a lot of RAM. You're not going to consume a lot of RAM, processing speed, and also the bandwidth, because for them they are light in their operation. They are light in their operation. Another reason, static route has the following, static route has the following disadvantages. Number one, initial configuration and the maintenance is time consuming. As we see, when we begin configuring static route, you see that this thing is going to consume some time. So that's one of the disadvantages. Another disadvantage, configuration is error prone, especially in large networks. Now when the network is very large, you are most likely to make errors, because when you are configuring static route, you have to mention every remote network to a particular router. So just imagine if you have like 20 remote networks which you have to configure with static route. Someone can make an error. Instead of typing 1.0, you can type 3.0. So that one will affect the entire operation of your connectivity. So another disadvantage, administrators' intervention is required to maintain changing routing information. Another disadvantage, it does not scale well with growing networks. Maintenance becomes cumbersome. So if you are adding other new routers, other networks, it is going to be cumbersome because you have to go on each and every router and inform them about a new remote network. So it becomes tiresome. Another disadvantage, requires complete knowledge of the whole network for proper implementation. When to use static route? Static routing has three primary uses. Static route has three primary uses. What I'm doing, I'm explaining how static route works. Then from there, we shall be able to apply whatever we have discussed into a lab. We have to do a practical lab using packet tracers. So I'm just taking some time to explain how the static route works, why we need to use it, what are the three primary uses of the static route. So one of the primary uses of the static route is it is made for small networks, providing ease of routing table maintenance in a smaller network that are not expected to grow significantly. Default route is another primary use. We shall see also that. Routing to and from stub network. Now this is something also very important which you have to understand. In networks, when we talk about a stub network, this is a network that is accessed by a single route. A network that is accessed by a single route, and the router has no other neighbors. Okay, so like for example, if you look at this one here, we have this kind of network here. And this one we are calling it a stub router. And what has been highlighted here, this is what we call the stub network. So in simple terms, when we talk about a stub network, it is a network accessed by a single route. A network accessed by a single route. Static routes are often used to connect a specific network. They can also be used to provide a gateway of last resort. We shall see that. It can also be used to summarize routing table entries. We shall see that also. And also it can be used to create a backup route in case a primary route link fails. We shall talk more about the backup routes. So this is the syntax we are going to use when configuring static route. This is how we are going to configure our static route, or the syntax we shall follow. The syntax is very simple. We shall say IP route, then you put your remote network here, and the subnet mask of that remote network, then you put the gateway address, or you can put the exit interface. Any of the two can work. We shall see that one. But at the moment, I want you to get the syntax, how we configure a static route. The syntax is IP space route. You put your remote network here, then the subnet mask of the remote network, then you put the gateway address to that remote network, and then you are free. You can also use the exit interface. So one of them can work. You either put the exit interface or you put the gateway address. So everything is explained in this slide. So in this slide we have a simple demonstration of how the static route is configured. If you look at this topology here, they are showing us how the static route is configured for this router 1. They are showing us how the static route is configured for this router 1. Now let us understand this very well. The first thing to do always before you think of configuring static route is to first identify all the remote networks for a particular router. That is the first step. So if you look at router 1, let's identify the remote networks. The first remote network is this. Remember I told you, look, you count the cables. So this is the first remote network. This is 1. We have another one here. This one is also another one. This is 2. And we have also another one here. This is 3. You count the cables which are connecting to the routers, but those cables are not directly connecting to router 1. So when I'm on 1, I will have, this is 1 remote network, this is 2, this is 3. So that is why in this configuration we have 3 static routes, 1, 2, 3. Why? Because we have 3 remote networks. So remember the syntax I told you? We say IP route, then you put a remote network. So our remote network is already given to you, it is here. 172.16.1.0, and the subnet mask of this network is /24, which is 255.255.255.0. Then I said after that you can either put the exit interface or you can put the gateway address. So let's see how we got this address here. When I'm here and I want to send data to this side here, this is how data is going to flow. Data will move from here. The first IP address of the router it comes across, that will be the gateway. So this IP address is a 172.16.2.2. So that is how we have got this thing here. This is the gateway address to this network. The same applies to this. If I want to add another remote network to this router, I will say IP route. The remote network is given here, 192.168.1.0, and you put also its subnet mask, which is 255.255.255.0. Then the gateway is very important. When you are here and you want to send data here, this is how data is going to flow. Data is going to move like that. The first IP address it comes across, that will be the gateway. So the gateway is 172.16.2.2. So you find out that the same thing applies to this. If I'm here and I want to reach this network, it will still be the same gateway. So the next thing we are going to do now is to go to part 2 of the configuration of static route.